concentration of a solution can be measured in various ways. If you have 10 grams of sodium chloride and 90 grams of water, that is a 10% solution by mass. Reason? We define it as the mass of the solute, that's 10 grams of the salt, not divided by the mass of water, but divided by the mass of the solution, which is the whole enchilada, 90 plus 10. So therefore 10 over 100 times 100 is a 10% salt solution. 10 mils juice and 90 mils of water would be 10% by volume by the same analogy. If we had 58.5 grams of sodium chloride in 1 liter of a solution, I notice that that's the molecular weight of sodium chloride, 23 plus 35.5. Therefore, we have 1 mole of solute in 1 liter of solution, and since molarity is defined as the moles of solute over the liter solution, that would simply be 1 over 1, so we have a 1 molar solution. Now, if you give the amount of solvent explicitly, then we're in a position to figure out what the molality is. Notice the 1-letter difference, and that really should be a small m. You should not use a capital M for molality. Small m, definitely. And in this case, since we define it as the moles of solute per kilogram of solvent, we once again have a mole of solute, 58.5 grams, and we do have 1 kilogram of solvent, so this is a 1 molal solution. If you have specific mole amounts for each one, we could do the mole fraction. You have to make sure that you add up the total number of moles. It looks like 1 mole of sodium chloride and maybe 9 moles of water, and therefore it would be 1/10. The mole fraction would be 0.1 since it's the moles of solute divided by the moles of solution. Whenever we talk about solutions, we should be aware that they can exist in all phases. A gas-gas solution could be air, where nitrogen is the solvent, less abundant is oxygen, therefore the solute. A gas-liquid common mixture is soda, where the solvent would be your water, carbon dioxide is your solute. Gasoline would be an example, or vinegar of a liquid-liquid solution, where in this case it would be water, and acetic acid, where you have 5% acetic acid. Lots of times salts dissolve in water. Those would be classic solid liquid solutions. The ocean's an example. We have water with salt dissolved in it. And brass and things like that are examples of solid-solid solutions. I chose filling since that's an interesting thing. It's an amalgamated substance, meaning that mercury is alloyed with silver in order to make those fillings.